This is a tutorial for Chapter 21, Section 8 on regression. So Chapter 21-8 basically talks about taking data and being able to fit a curve and determine whether data is linear, nonlinear, um, whether you have like what they call outliers, um, and it allows you to interpret data in a pictorial or in a graphical display. If I was to look at this data here, I'd have a hard time telling whether this is linear data, if it correlates to each other, um, exactly what's going on there. And so this all starts out on page 669 of our technical math book. And on page 670, we talk about the correlation coefficient. So the correlation coefficient. All right. And uh, table 21-12 give us a great uh, way to organize our data. And so I've taken the data from question number 7 and put it into here, and we're going to do just a little bit of formatting. And I'm using table 21-12 as my guide for this. So I'll do an xy, and then I'll do an x squared. I'm going to put that squared in a superscript, and then I'll do a y with a superscript squared. Okay, and then over here, and we're going to call these our variables. Okay, and I want to make a graph, or I want to make a table that's going to be big enough for me to use and just plug data in. And so down here, I'm going to add these up, and we can see at the bottom of table 21-12 we have a summation. So I'm going to do a double bottom border here. And down here, I'm going to insert the summation symbol. And I'm going to align this symbol on to the right. Okay, and xy is just that equals x times y. X squared equals x times x, and y equals y squared, excuse me, y equals y times y. Okay, I'm going to grab those guys here. I'm going to control C, and I'm going to fill. Now I don't have any data in this area, and that's okay. But again, like I said, I want to make a chart that's going to work well. I don't want to have to reorganize it. I want to be able to use this, quite a bit. And see, when I copy this down, it lost my bottom border, but that's pretty easy to fix. Okay. And then summation, I have my summation signal sign here. Maybe I want to make that bolder and make it just a little bigger so I can see it. And so I'm going to equal my sum of all my units there. And I can do this a couple different ways. You actually can see here summation, and it automatically grabs the data. Okay, so just click it, and it knows, the Excel spreadsheet knows that this up here is in a number, so it doesn't go all the way up there. It knows that that's the title. So you got all these great tools here. Okay, so now, and so I know what my data is down here. I might want to go and take this, and a lot of times the numbers are aligned to the right. For this, it makes a little more sense to put them in the center. So I like the way that data looks, and I think that that looks pretty good and is very similar to what we see in table 21-12. Okay, so now that we have our data organized in a little table, it's asking for the correlation coefficient. If we look at that formula that's on page 670, it looks like a pretty complicated formula. And let me pause here for a second and I will write that formula up here. Okay, this formula looks complicated, but it's really not. We only have a few variables here. We have the n variable, we have summation xy, we have summation x, summation y, and then we have summation x squared and summation y squared. The thing about this formula that can be confusing is just simply the order of operation. So I'm going to try to show with brackets the order that we would do things here. Okay, so that would take care of the top. So we basically take n times the summation of xy minus summation of x times summation of y, and that gives us our top number. That's all divided by this information down here. So down here, I'm going to go inside the bracket, inside the square roots, and kind of work my way out. So I've got that. Okay, and then in here, okay, and then again over here, same thing. Okay, so that kind of helps me see how many parentheses I need or what I need to do when I go and write this. And again, you could use this in your calculator, but Excel can do all of this for you. So I'm going to make a new page right now, and we're going to go through how to create a formula in Excel that has the variables. So this is going to be our correlation coefficient. Okay, and in here we just talked about our different variables, but this is formula 355. Formula 355, and this is correlation coefficient. Okay, I'm going to come up here, I'm going to merge these cells, make this kind of a nice little formula box here. Okay, and in here, what did we talk about? We had the n variable, then we're going to get the summation symbol, so we go to insert, symbols, insert. Okay, close that. I'm going to highlight and control C that symbol so I don't have to remake it every time. But we're going to have the summation of x, and the summation of y. Going to have the summation of xy. We're going to have the summation of x squared. I'm going to put that in a superscript. And I might just grab that whole thing there, bring that, copy it. Oh, the superscript dropped. I thought I'd save a step, but I didn't. Then I could just change that y. But sometimes those formatting options don't stick. All right. To make this nice and neat, I'm going to align everything to the right. So these are really what I'm going to put here. I'm going to merge this. These are my variables. Okay. And so down here, I'm going to have R, and that represents summation or the correlation coefficient. Okay, and let's go back here and take a look at our formula. So when we looked at this, we started with two parentheses, Okay, and that ended, a minus, a start, that formula, we end, and then we divide. So let's do that part first. Okay, so I'm going to hit equals, two parentheses, n times the summation of xy. See the summation of xy there? Close parentheses, minus parenthesis, summation of x times the summation of y. Close parenthesis, close parenthesis. You see how it highlighted that? We've got the color codes black to black. Now what do? We divide. And let's hop back over to our screen. When we divided, we had two outside brackets, a square root, and then two inside brackets. I want to remember that because that's going to help me get started here. It's very important that your order of operation is correct, or you'll have a hard time making it work. So that was two brackets and then square root. So SQRT, and then two, again I had two in here, and then I did, in that first set, I did n times summation of x squared. So n times summation x squared, close parenthesis, and then I had a minus, and then this guy's had a little parenthesis here. Now, it's summation x squared, so summation x to summation x. Okay, that's squared, correct? If I times it by itself twice, that's squaring it, just like right here. And then I have close, close. And that's perfect. Did you see this tangerine color kind of highlighted? And that says that we completed, watch again, see it highlights it there. We've completed that first step. And then what do we do here? We're multiplying. Okay, this is no different than saying, right? So we're going to multiply that. And then here I did the same thing, one bracket, then the square root, and then two brackets, okay? One bracket, square root, bracket, bracket, n times the summation of y squared, close bracket, minus, I know that from here, so n times the summation of y squared minus summation of y times summation of y. And then what am I going to have out here? 3. Okay, and since I don't have the squared here, I'll actually have 4. So summation of y times summation of y, parenthesis, 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 4 of them. You can see my black to my black. Okay? Well, it says I'm divided by 0. So how do I test this? Well, example 72 give us some numbers. So let's punch those in. So in example 72, we're given n equals 11. And we go down to the sums, and we see sum of x equals 55. I'm getting this from table 21-12. We see that the sum of y equals 60. Sum of xy equals 353. Sum of x squared is 385. And the sum of y squared is 364. And in example 72, right above table 21-12, if we see what r equals, it says r equals 0.834. Well, we've got more digits here, so if we want to format that cell to 3 decimal places, it's a number, 3 decimal places, 0.834. So we now know that our formula that we've written here works perfectly. So I'm going to box this guy up, black thick border. I'm going to highlight this yellow because that's my answer. And then I'm going to highlight these a different color, indicating that, whatever color you'd want, it doesn't matter, indicating that I need to fill those in when I go and put this formula somewhere. But so now I have my correlation coefficient formula all done. So for number 7, I have all this data here. So what do I want to do? I just grab my formula, my information, bring it over here. I drop it right here. Now in, where did it equal? In here, I have 1, 1, 2, 3, 4, 5, 6. So that equals 6. Okay. Summation of x is right here. Summation of y is right here. Summation of xy is right here. Summation of x squared is here. Summation of y squared is here. Automatically calculates, and the instructions say to 4 decimal places. So what do I need to do here? Just right click, format the cell, 4 decimal places, done. And here's my answer. Number 7. Okay, on to number 8. Find the least squares line. So what does that mean? That means it's taking, and since it can't, these data points don't make a perfect graph. If I was to graph these, if I was to graph this line, it's not going to be a perfect line. It's not going to be linear. So I want to do a least sum squares, which basically is a way to calculate the slope intercept. It's basically a way to calculate the slope intercept. So I'm going to put that formula down here, and then I'm going to do a new one, rename it, and least squares. Okay. So this is on page 672, formula 356. And this is formula, and it is used to solve for the slope intercept which equals y equals mx plus b. Okay, so, and this is talked about linear regression, where it's a nice straight line. It's talked about on the top of page 671. And since this data isn't a straight line, we can't do that. And so, again, um, for this formula, what do we want to find? We're trying to find the slope intercept. We're trying to get basically a straight line that would go along with this data. And so again, we're going to look at what variables we have. And let me pull these formulas up real quick, and I'll pause and write these out, and we'll talk about them for a second. Okay, so We have the slope, which is represented by m, and b, which is the intercept, where the line would cross the y-axis. And so um, again, if we want to look at this, let me pause this just for a second. I want to show you one other thing. Okay, so let me just draw this XY graph here real quick, okay? So I have my x-axis and I have my y-axis. Say I have data scattered all around, okay? What this does is this allows us to kind of come up and say, hey, I have basically a line that has a certain slope. So the slope of the line is the slope equals the rise over the run, and we have, and that equals m, and then we have b, the location where that line crosses the y-axis. And so if I'm trying to interpret this data, or I'm trying to characterize this data, I may want to try to fit a straight line to this data that isn't straight, just to give me an idea of what's going on. You know, maybe I have data that's, you know, stretched out really far, you know, and I have some outliers here, but you know, it might be pretty tough for me to tell where that data all lies. But with this formula, it'll allow me to be able to get an idea of some data trending or whatnot. Okay, so that's what this formula is doing, is it's taking and mathematically putting this in a way so we can do that. So what I'm going to do here is, again, just like we did before, okay, put brackets. I'm going to set up where I need my parentheses. So M. So I'm going to go back over here to my Excel spreadsheet. Over to my Excel spreadsheet, and I'm going to put M. Okay. Now I'm going to do a formula for B. I'm going to put both of these guys to the right hand side. So looking very closely at, oh, gotta put in my variables, don't I? And my variables are similar to these guys, so I'm just gonna grab these over here. Okay. No sense reinventing the wheel there. Okay. Um, just so we're clear though, there is one variable that we don't use in here at any point in time, and that is the y squared. We never use the summation of y squared. We do not use that one. If we look through all of this, we don't have anywhere, we have the summation of y, we have the summation of x, the summation of x squared, xy, but there's no y squared anywhere in here. So I'm going to get rid of that one variable so we don't accidentally use it. So based off of what I just did here, I'm going to start off with two parentheses, do this formula, close the parenthesis, minus parenthesis, close, close. Okay? So follow along. So n times summation xy, close parenthesis, minus parenthesis, summation of x times summation of y, close parenthesis, divided by, come back over here, I've got two parentheses here on the bottom, parenthesis, parenthesis, n times summation of x squared, close parenthesis, minus, and this is summation of x squared, so summation of x times summation of x, close, close. Okay, we don't have any numbers in there, so it's going to do a divide by 0, and that's okay. B, so we're going to come down here to the intercept. Let's put our parentheses in for this one. So I'm going to parenthesis there, bracket, bracket, parenthesis, 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 bracket, bracket. So I'm going to start with 2. Go ahead and go and do that. So summation of x squared times the summation of y, close parenthesis, minus, start parenthesis, summation of x times the summation of xy. And you should be following along in the book on page 350, or formula 356, page 672, divided by, here, 2 parentheses, okay? N times the summation of x squared, close parenthesis, minus summation of x squared, summation of x times summation of x, close, close. Should be good. Again, how do we check this? Well, we're given this data in table 21-13, and we're told that if we count down in table 21-13, we have 11 data points. Summation of x is 55. Summation of y is 52. Summation of x squared is 385. And summation of xy is 186. Okay, then I look over on page 673 and I see that my x, or my m, is minus 0.67 x plus 8.1. For the n, we had 1, 2, 3, 4, 5, 6. For summation of x, we have this guy. Summation of y, we have this guy. Summation of xy, we have this guy. And summation of x squared right here. There's the answer. So if I'm going to write this out, if I was to write this, I would write y equals 2.92x plus 0.674. And it depends on how many decimal points we need to roll that out. And there's my answer. Okay, pretty easy. And so now we can go on to number 9. And so you go, well, shoot, I don't have that data. It's not, I don't want to have to do that whole entire thing every time. Well, depending on how you want to do it, if we actually kept both of these on the same one, like we were kind of talking about doing there a second ago, we could actually just copy everything over. So I just copy all this, Control C, and come over to number 9. Just come over here. I can drop it anywhere. I've got these guys. I'm going to Control C. I'm going to copy it. I'm going to delete that guy out. And I'm just going to come right here, Control C. Did you see how everything automatically calculated? Now the only thing that we need to do is this guy. 1, 2, 3, 4, 5, 6, 7. 7. So these all updated because I had them. It automatically calculates. I have to put that in there. So maybe I should put this guy bright red so I remember, hey, I have to put that in. Okay. And so my coefficient for number 9 is done. Now, do you see how quick that was? That's very nice to be able to have that option. Once you've put that work into Excel, you're able to automatically have all those cells calculate, and the answer is -1. Okay,